Okay, so just reviewing terminology, because you got to know what these things are called. Because if I ask you to do something with the basic reciprocal square function, you better know what the basic reciprocal square function is. I'm not going to necessarily tell you. Probably won't tell you. I want you to know the terminology. I want you to know how these functions classify, because that's going to become very important very shortly, like within the hour. Okay? So reciprocal means, like, put it under 1, right? So the basic reciprocal function is 1 over x. Reciprocal square, well, 1 over x squared. Basic squaring function, x squared, right? Basic cubing function, x cubed. The words go right with it. Now, exponential function is 2 to the x. That's the only one of the 5 most basic functions that we talk about that isn't totally obvious, but it's 2 to the x. X is in the exponent. That's why we call it exponential. Then, of course, you got a couple of inverse functions. Okay? Inverse to the exponential function is the base 2 logarithmic function. Okay? And you did real well with sketching the inverse graphs and stuff like that when we did it. And you got to know how to do those things. Okay? Sketch an inverse, what do? You just reverse the columns. Sketch the graph that results. Okay. Anyhow, now what we want to talk about is this. Okay, let's say we've got the graph. Let's say we go out to 4 here, and we go up to 4 here. Okay? And we've got a graph that looks like this. Now let's see. And that's not at all symmetric. It was supposed to be, but there it is. Ah, that's so bad I've got to read a lot. I can tolerate slightly lopsided graphs, but that was ridiculous. Okay, so I'm going to do this. I'm going to put a point here, and I'm going to put a point here. I'm going to put a point here, so I can kind of keep myself straight, and then maybe I'll get a reasonable graph. It still isn't great. Okay? Now, what's that graph look like? It looks like your basic squaring function, except it isn't, because it doesn't have a vertex at the origin, right? Okay? But it shifted to the right and up. Okay? And maybe vertically stretched. Now, what kind of relabeling do you do on the basic squaring function if you want to shift it to the right? Going to subtract what? Same way to shift it to, well, okay, let's see. How far to the right does this thing appear to be shifted? Well, the vertex appears to be here, so it appears to be shifted this far to the right and this far up, right? On this scale, this is a little more than halfway to 4. You know, I could subdivide, if I can subdivide it accurately to find my units. Okay? And I can subdivide this. I'm going to try to do this as accurately as possible, but I don't expect miracles. Okay? So now it looks like, this looks like about 2.2. This looks like about 1.4. Okay? So we've shifted the basic squaring function shift 2 units horizontally. And 1.4 units vertically. Question, because we don't know if it's been vertically stretched. Okay? We can't necessarily tell. So what's happened to our interval from -2 to 2? Well, the middle of that interval is shifted over to 2.2, right? Okay? So we have to add 2.2 to the middle of the interval, which means we're probably going to add 2.2 to the endpoints of the interval. Okay? So the relabeling okay? And then, what does our basic y interval become? Well, our basic y interval, the range of the squaring function, is from 0 to 4, right? Okay? And then, because of course the vertex has to go from 0 up to 1.4, right? You got to add 1.4 to all these coordinates. Okay. That replaces the interval with 1.4 to 5.4. So let's just see how that works if we actually do it. So here's our vertical axis point. And here's -2, here's 2, up here's 4. Subdivide, here's 1, here's -1, here's a half, -half and a half. So here's 2, here's 1. Here's 1/2, here's 1/4. So, we've got these points. Again, not drawn all that well, but there we have it. Okay? And now we relabel this so that this point becomes and remember, we put this in parentheses and this in parentheses. Also, and I didn't remember to do it, we use dotted lines here. So I'm not going to smudge those out to make them dotted. But generally, we'd make these lines lighter so we can see where the new axis is. It's especially important if you're not color coding. I can color code it so we can see where things go. Okay? So this becomes 0.2, and this becomes 4.2. And then the y-axis is you're going to have to go a little bit to the left of 0.2, right? So that's going to be about here. So here's our y-axis. And then, where's our x-axis going to be? Well, 4 is going to become, parentheses here, 4 is going to become 5.4. 0 is going to become, let me, that's okay. 0 here on the y-axis will become 1.4. Let's do this. Let's label it over here. We're going to put 5.4 here. We're going to put 1.4 here. And now we see that a unit is here. So if we go down here, 1 below that, it's going to be 0.4, and 0 is going to go about here. So that now our x-axis is down here with 0.2 here and 4.2 here. Does that make sense? Y'all done pretty well with relabeling. So I expect if you've done the relabeling, you pretty well understand what we've done. Now the one thing we're doing here that we haven't done before, we've relabeled the y-axis or we've relabeled the x-axis, but we haven't relabeled them both. Don't think we've done that. If we have, we've only done it once. It doesn't this kind of give you this? Okay? So this shifting and so forth is totally equivalent to relabeling. The other thing is now that this function would be then x minus 2.2 squared plus 1.4. So if we plug 2.2 into this expression, what do we get? I'm sorry?
4.4?
No, but you added them. That's a minus, right?
Oh.
Plug in 2.2, we're going to get 0. If it's added, we would get 4.4. That would have been right. Okay? So if we plug in x equals 2.2, we get y equals 1.4, right? Well, if x equals 2.2 on this graph, y is going to be 1.4. So, here, 2.2, we already know this is 1.4. Okay? Okay, well, there you have it. Now, we don't know if we've vertically stretched this thing, so another thing that could happen is you take the basic squaring function and you relabel. Right, a lot of things done without thinking. We want the y interval (0,4) is going to become 0,8. Then, after doing that, not the x-axis, the x-interval, by adding -1 to each x-coordinate, and then the y-interval 0, 4, by adding -2 to each y-coordinate. Okay. So, so we sketch relevant points. And there's our graph. Okay? Now, first thing we do is this y-interval becomes 0 to 8. So we no longer have the 4, the 3, the 2, and the 1. We've got an 8 up here, which means we've got a 4 here, and a 6 here, and a 2 here. Okay? Then we add -1 to each x-coordinate, which means that we no longer have these coordinates. We have the interval from -3 to 1. And then we're going to add -2 to each y-coordinate. Okay? So, probably should have used a different color. So I'm going to kind of make the 8 and the 6 and the 4 and the 2 into orange labels, so I can use a green label for my final y-coordinates. So I'm going to subtract 2 from each y-coordinate, okay? Which is going to give me, well, before I do that, we see that in relabeling the x-axis, the y-axis has moved, right? The y-axis appears to have moved to here. So we know we need at least this much y-axis, okay? And what else? Well, now we know what the coordinates are going to be, so this coordinate here is going to become 6 because we subtract 2 from every y-coordinate. We get 4 here, we get 2 here, and we get 0 here. And for that matter, the 0 that we have here becomes -2. And then, of course, the y-axis keeps going. But this is all we're going to need. Okay, so there's our new y-axis. Now, where's our new x-axis? How can you tell where the x-axis is once you got the y-axis labeled? Got to go through 0, right? So here's our x-axis. And here's the y-axis. And now we see that this graph, the effect of this relabeling is to shift the graph 1 unit to the left and 2 units down. Okay? So the new vertex is -1, -2. Now the function first transformation, 0,4 has become 0,8. Okay? What's happened to the y coordinates? Like, y coordinate was 2, now it's 4. Y coordinate was 3, now it's 6. Y coordinate was 4, now it's 8. What's happened? They've doubled. Okay? Well, that means if y was x squared, now it's 2x squared, right? Because the basic squaring function was y, was x squared. That's your basic squaring function. Now it's 2x squared. If you double all the y coordinates, that's what happens. And you can figure it out. Like if x equals 1, what's 2x squared? Tough one. Plug in 1 for x. What's 2x squared? No, you're not squaring 2x, you're just squaring x. If I wanted to square 2x, I'd have parentheses around it. But yeah, that was good thinking anyway. Okay, just bad order of operations, but good thinking. Okay, you'll fix it. Okay, I'm sorry. You said. I think. If you plug in 1 for x.
Yes, it's weird.
Yeah, but you got 2x squared.
2 squared?
Pointing to this, right?
2 times 1 is 2.
Yeah.
Times 2 is 4.
No.
No.
Well, if x is 1, 2 times
If x is 1, what's x squared?
32.
You just said it is 1, right?
Yeah, but
You're not squaring the 2.
I know, but if you do 2 times 2, or 2 times 1.
You don't do 2 times 1 because you do exponents before you do multiplication. Okay? That's a common thing, and same thing she said. Okay?
No, I got confused when you said it. I was like, what?
Okay, well, whatever.
I do
Whatever.
know what order of operations.
Yeah. You got to follow the order of operations. 2, it doesn't get multiplied by x. 2 gets multiplied by x squared because you do the exponent before you do the multiplication. Okay? Very important. Okay? So you get 2x squared. And if you want to, you could even say, well, if you're doubling x squared, it means you double x squared, right?
Yeah.
So you could put parentheses there. But without the parentheses, it still means the same thing. And if you wanted to square 2x, the parentheses would have to go all the way around the 2x. Then you'd be squaring the 2x. then you'd be multiplying x by 2 before you square it. Okay? So, I want to make sure we understand this. But anyhow, there it is, 2x squared. Okay, so, where are we now? Okay, our first transformation was our 0,4 became 0,8. If you do that, then all your y coordinates get doubled, as you see here. Very important. They all get doubled. Okay. Now what happens? Okay? Well, now you add -1 to each x coordinate, right? So y equals 2 times x minus 1 That's not right. Okay? Because that's not going to work. Okay, so think about it. If x equals 1, what's your y value going to be? Well, it's going to be 0, right? Okay? But if x equals 1, your y value isn't 0. If x equals 1, your y value is up here. Okay? So what you got to say is, this is x plus 1 squared. So now if x equals -1, which is the new labeling, that's going to make it work out that you get 0 here. Now we haven't changed the y-axis at this point, so this is still, your y is still 0. Okay, still in the original y-axis, so we got 0. Then, then we add 2 to each y-coordinate, so the y-coordinate does become 2 less. Okay? So there's our function. Now let's see if that function seems to match the graph according to our new set of axes.